right, hello everyone. Welcome. Um, so today we're going to have a few topics to cover. So we're going to start by talking about uh, interfaces, which is necessary to pick up from last time. My camera's in a different spot, but I'm not liking it. I'm moving it back. Also now you can see Kitten, and that's important too. Being able to see Kitten. Anyway, there we go. From there, we're going to talk about two particular interfaces, comparable and comparator. And at that point, you'll actually be ready for homework 3. My plan is to release homework 3 tomorrow. Are there answers for the daily assignments? There are not at the moment. It's something that we typically haven't done, but it's something that if people insist, we could maybe do. This is Stuart. This is my baby. Um, so it's not something that I have yet. Anyway, he apparently didn't like me petting him. He's now licking that spot. Anyway, but from there, we're then going to talk about generics and how they relate to abstraction. To that end, though, everyone, of course, is thinking about midterm exam 1, which is tomorrow. No lecture tomorrow. The exam will be, at this point, 1 hour. If I change that time, it will be to expand it, and I will give you plenty of notice, but I find it incredibly unlikely it will be less than one, or it'll be more than 1 hour. Is the midterm going to be as hard as Dark Souls? Never played it. Here's the thing about exams. If the scores are low, then that tells me I made the exam too hard, and then I curve. I don't plan to curve. I don't think this exam is too hard, but we'll see. So the exam will be 1 hour in duration. Keep in mind that the duration is related to the size of the exam. How many questions? Not finalized yet. Also, the problem with that is that some of the questions should take you 5 to 10 seconds. Some of the questions may take you a couple minutes. So it's not really an accurate measure. All multiple choice, no. It is not all multiple choice. It is mostly multiple choice. There will be coding portions. 2 to 3 coding questions. When can we expect to see homework 0 and 1 grades in? We're still working on those. The top priority is getting the exam out. Are the multiple choice generally the same difficulty as quiz multiple choice? Can't say. Difficulty is purely subjective. I can say that there's going to be more code reading. You're going to need to be able to read and interpret code. That's something that we don't tend to make you do on the quiz, that you will definitely need to do on the exam. It's about as specific as I'm willing to be. Difficulty subjective, so I don't want to say. But that said, I would say on average people find reading and interpreting code more difficult than memorizing definitions. So you could argue more difficult. I'm really not trying to be coy. It's always subjective when I say, do I think the exam is difficult? Do I think it's difficult? No, but I'm teaching the class. My opinion is not valuable in that respect. So I one of the difficulties is whenever I write an exam, I never know how well students are going to do on it until they take it. Pardon me, needed some water there. Anyway, so it's mostly multiple choice. There are coding portions. Most of the questions are what I would call form questions. By that I mean mostly multiple choice, fill in the blank, matching. These are form questions. They're graded completely objectively. There's no opinion as to whether or not the answer is correct. There's no interpretation. The coding portions will be partial credit. The form questions will not be. Because how do you do partial credit on a multiple choice question? Can't really. There are actually some that are, but like it's things like select all that apply, and we'll, you'll see on the exam. But this is most of the exam. In fact, this will be 80% of the points. That doesn't mean 80% of the questions. It just means 80% of the points. The coding portion, 20% of the points. Are there going to be material covered in the readings? Yes. Yes, there are. So I'm not. So this is just so you know ahead of time. If you really struggle with the coding portion, that doesn't mean that you're going to fail the exam. Similarly, though, take the multiple choice section seriously because it is a lot of the grade. So these percents I'm willing to give of the points. It's not to say they're 80% of the questions or 20% of the questions. The coding questions individually are going to be worth more points than the form questions. But the overall exam mostly leans towards the form questions. Hang on, let me. The exam will be available starting at 1 p.m. Eastern. It will be available until 11:59 p.m. Eastern. And that's daylight time, obviously. From there, just please take a moment to recognize that if you start the exam at, say, 11:30 p.m., then you will only have 29 minutes. So you will get an hour. If you have accommodations, I'm already working to make sure you get those that extra time as needed. But from there, you will get one shot at this exam. I want to be clear. I recognize this is an online course and it's difficult to guarantee at times that you have stable internet, etc. Unfortunately, the reality is because there is no way for me to verify whether or not someone's internet goes out, you need to do your best to make sure you have stable internet and that you are going to be able to work for the exam time straight without interruption. That needs to be on you because there's no way for me to reopen the exam. The exam questions will save as you enter every time you switch pages because questions will be on multiple pages. There'll be more than one question per page typically, but there will be multiple pages. Every time you switch pages, it saves your work. Do we need to comment? Again, I said this before. I will never tell you you don't need to comment your code because commenting your code makes it more readable and easy to understand, and that will help the graders potentially give you more points if they are having trouble interpreting your code. If you have hard to understand code but no comments, it's likely you might lose points that if you explain it with a comment, you wouldn't. So I will never say the phrase, you don't need to comment your code, but we will only use it as needed, is what I will say. Are we doing exam review today? In so much as I have time left over, but I do need to cover content. The content in this class is needed to be covered for 2150, and so to that end, that takes precedent over any review. Alright, so with that, make sure you have stable internet during the exam. And we'll go from there. Are there any questions? Originally, yes, we would have done a lot of midterm review today, but I did lose a day of class. So I'm trying to make sure we cover material because there is material today that is on the exam tomorrow. So I want to make sure I cover that, as well as try to get some time for questions. Are there any questions about the exam? It will be on Colab, I should say, and maybe that was, maybe I have said that before, but I think it might fall into the category of it's obvious to me, so I didn't say it. It will be on Colab. It is open. Note, internet. book. IDE. Limitations on internet. No communication, by which I mean no talking to other people in this class, outside this class, whatever. That includes no posting on any discussion sites, whether that's coding focused sites like Stack Overflow or Chegg. Well, Chegg's not really coding focused, Geeks for Geeks. Whether that's just general schoolwork focused, whether that's Facebook, whatever. If I find that you violate this policy, you will get an F in the course. Which, hopefully me saying that's completely irrelevant, but I want to be very clear. I do search for our questions on all the popular sites, and I have failed a student before because they post an exam question during the exam on a website. So internet means you're welcome to look at things. You are not welcome to post things. Does that distinction make sense? And again, the simple reason I allow this, if this were a normal term, I would not allow any of these resources. It would be, you get one note card and what's in your head. But I'm not going to do something that only punishes honest students. So, to that end, are there any questions about the exam? Not content related, but logistics related, because I want to make sure everyone understands that. I'll give another couple seconds for a post, and then I will move on to discussing interfaces. By the way, in case you were wondering, this is how I play music before the stream starts. I just use YouTube. All right. So today, let's talk about interfaces. So here we go. What do all of these things have in common? What do all of these things have in common? Here we have, I believe this is a nail gun of some kind. I'm not certain of that. Oh no, this is a buffer. This is a sander. They are machines, but what about them is in common? So you have like a space heater, a lamp, coffee pot, etc. They're things around the house. There it is. They use electricity. How do they use electricity? How do they use electricity? Because I'll tell you, none of these are battery powered. Notice there's a cord. The lamp would have a cord. Well, to function, yes, but how do they get their electricity? That's the question. Where does their electricity come from? Wall cord. There we go. It comes from this. If you're in North America, this is what it comes from. This is an agreed upon standard outlet that North America uses. Now, this is, of course, North America. There's different interfaces in Europe, different interfaces in Asia, for example. Australia, I think. Does Australia have their own, or they use the same as most of Asia? I'm not certain of that. But the point is, there's different outlets, and if you've ever traveled, you've probably had to bring one of those adapters with you. I have one that has like all the different top outlet formats. This is not universal. But what this does mean is that if I want to make a product, if I want to make a computer, a lamp, if I want to make any electronic product to appeal to a North American audience, I need to include some means to connect to this. So back here, I have my electric guitar amp. This is my electric guitar amp. And it has a plug on the back up here. Also some cobwebs. That's lovely. But it has a plug here that you plug in a power cable that runs to the wall. And the key is it has to run off that outlet source. And in North America, that outlet provides a constant or near constant wattage. In North America, that promises, or at least you should assume generally, unless there's a brownout or something, that you are getting 120 volts alternating current. Now, actually, there are still some places in America that use direct current. I think Harvard, some of their dormitories are old enough they still use direct current, and so students can't bring their appliances. But broadly, you can expect 120 volts alternating current coming through the outlet. And so, when you, as an engineer, are building a product that needs power, you have to take into account this interface, and you have to design your device such that it adheres to this interface. This is an interface you have to adhere to, not because it fell from the sky. This didn't come down from the sky. It wasn't etched on a stone tablet, right? Human beings designed it this way. But this is such the widespread standard that you, to make a device that can be powered in the home, need to adhere to this standard. In Europe, by the way, they don't use 120 volts alternating current. They use, I believe, 240 because it keeps the amperage lower. So you have to consider different standards at times. But generally, for this audience, this is a standard interface that you apply to, that every powered source is designed to adhere to. And that takes us to this idea of interfaces. With interfaces, it can mean a lot of things, but we are talking about a specific kind of interface. So far we've talked about this thing called an API you may have seen in the reading. The API of a class are the public methods and fields that a user has access to. That is not the kind of interface we're talking about. The interface we are talking about is an interface that defines a standard set of methods to perform a particular function. Define a standard set of methods to perform a particular function. Now, this is similar in concept to what we talked about with this abstract class yesterday. Remember our abstract class triangle? Our abstract class triangle it had methods that it could give as like homework assignments to the kids, little chores. The child classes had to implement these. And like abstract classes, you cannot directly instantiate an interface. But an interface may look something like, let me pull this over here. You don't need to see my downloads folder. An interface may look something like this. Drawable. This is an interface. Public interface instead of public class. The interface has a name, and it defines abstract methods. Abstract meaning these methods are not implemented. Interfaces cannot have constructors, they cannot have working code, they cannot have fields. All they can have are abstract methods. And technically there's this thing called default, but don't worry about that because it's not relevant to this class. If you're familiar with default, cool. Not really relevant for this class. We're not going to expect you to know it for the exam. This is all an interface is, and you may think, well, why is this? What is the point of this? The idea is I am defining a standard means by which something can be drawn. Similarly, movable. I define a move up a certain number of pixels, move down, move left, move right. Point being, this these methods will have to be implemented by anything that adheres to the movable interface. The same way that any electric device has to adhere to this outlet interface. So we're defining a standard interface that other classes must adhere to. So say, for example, we had a timekeeper interface. Timekeeper had a method getTime and setTime. Timekeeper does not implement these methods. But it says if you want to make something a timekeeper, it must implement getTime and setTime. And so if I say public class watch implements timekeeper, necessarily, that means, by the way, we use implements, not extends when we're talking interfaces. That means that watch must necessarily have implemented the methods that timekeeper defines. So for example, if I say triangle implements drawable, then necessarily I need to write a function looking at the drawable interface, public void draw. And this could be, I'm not actually going to do any kind of graphics for now, so let's just do system.out.println drawing a triangle. In this, this is just a stopgap. But the point is, I have to have this method, because if I delete this method, I'm going to have compilation issues. My code won't compile. Now, it may seem weird that it's equilateral triangle and right triangle that aren't compiling. It's just because you can't directly instantiate this class, so it's kind of like passing the buck. Point is, someone somewhere in the hierarchy has to implement draw. And now when I save this, the code compiles. Unlike inheritance. See, inheritance, you can only have one parent. But in interface, you can adhere to multiple interfaces. Remember, when we're talking about when we're talking about an interface, we're not talking about an is-a relationship. I'm not saying triangle is a drawable. I'm saying triangle is adhering to an interface that says how to draw things. And that interface is defined as this function draw. Similarly, I could have movable, move up, move down, move left, move right. I can say that triangle adheres not just to drawable, but also to movable. And then, in order to move something, I have to have a center coordinate. So let's say I have, let's do private double center X, center Y. And let's say I center my triangle. An interface is defined within a class. An interface is defined in a file that looks like a class, but it's not. Public interface instead of public class. So this is a Java file, and on the face of it, it may look like a class, but the differences are, it's not public class, it's public interface, and it cannot have any constructors, variables, or working code. It can only have abstract method headings. So it looks similar on the face of it, but it is not a class. It is an interface. And then I'm just going to say for now, center X in the constructor equals 0.0, center Y equals 0.0. And then in these functions for move up, up means you typically increase Y. So I'm going to say center Y plus equals pixels. Move down is similar, except it's minus equals. Move left. We typically think of left as subtraction. So it's center X minus equals pixels. And center X plus equals pixels for move right. This is how I could implement this interface. I simply have to include these functions with the same interface. That is the same return type, the same arguments, the same name. Whatever I do with those, that's up to me. But I have to adhere to this movable interface. Is an interface kind of similar to a superclass? It is, yes. In fact, it behaves with the substitution principle exactly the same. It behaves with the substitution principle the same. So I can say something is a drawable as well as being a triangle. So it is similar. It is most similar to an abstract class. Can the methods be non-void? Sure. Yeah. In fact, there are times we're going to get to a very practical example of an interface called comparable and comparator where the methods return ints. And we'll get to a very practical example of that in a second. So the methods can be non-void. Yeah. From there, an interface is like an abstract class. It cannot be instantiated, but the extra limitations are it has no constructor, it has no variables, it has no working code. So it's actually easier than an abstract class. Otherwise, the same substitutability principles apply. So it's rather similar. One of the key differences, though, is that you can only extend one class. So right triangle or equilateral triangle extends triangle. They can only extend that. What is the point of the interface? What's the point of... Hang on. What's the point of this? Because if everyone in their own house found their own way to connect to the wall, it would be impossible to build products for a wide audience. The reason that we have this, and every house built will be built with these in North America, is, and I think actually South America also uses this, but I won't pretend to be certain of that. The reason that we have this standard is so we can design things with that standard in mind to be more broadly applicable. So think of interfaces less like an organizational structure and more like creating a standard for the purpose of broad applicability. And we'll see an example of this with comparator and comparable. A lot of functions will assume that that your data implements comparator or comparable, and if it does not, you're going to run into problems. So we're designing a standard. That's how to think of interfaces. It's a standard to be adhered to. And so, for example, because of the substitutability principle, if the watch object it's a great question, TFT. It is absolutely a great question. It's just, if we're thinking organizational hierarchies, we're probably going to do parent and child classes. We're not thinking of organizational hierarchies. We're thinking of standards. And while that seems similar, there is a difference. It's a bit nuanced. But again, we can do the substitutability principle. So if the class watch extends timekeeper, you can do this. This function that takes in a timekeeper can take in anything that implements timekeeper. So from there, all of these are true. If I say watch w equals new watch and watch implements timekeeper, then watch is an instance of watch, obviously, also an instance of timekeeper, and also an instance of object. The same way that a triangle, because the parent class triangle, it implements drawable and movable, it is completely fine for me to say public static. Actually, let me do this in triangle demo here. I can say, for example, system.out.println e instance of equilateral triangle. And that will print true. I can say E instance of triangle, and that will print true. And because triangle implements drawable and movable, I can say drawable and system.out.println E instance of movable. Oops, I spelled movable wrong, but otherwise it will work. And you'll see that all of these are true, all 4 of these. Any questions about interfaces? We're going to get to a much more practical example soon, but I just want to make sure everyone understands the mechanics of interfaces. To this end, it's actually worth noting that the list class, remember how we've talked about how you can say something like list triangle, well, actually I already have it. You can say something like list triangle equals new array list. List is actually not an abstract class. I lied. List is a interface. So again, we've talked. So I've mentioned the benefits of interfaces. It's designing a standard. If you don't have a standard, it's very so. Let's take, for example, one of the issues the Confederacy had in the Civil War. Among many, fuck the Confederacy. Forgive the language, but among many, one of the strategic issues, well beyond the horrific moral issues they had in the Civil War, was in the Confederacy, every state had their own standard width of a railroad track. Before the Civil War, actually, it was common for states to have their own width of a railroad track. But one of the things that was going on, among many things, in the 1850s, was the federal government was actually standardizing railroad tracks. So like the B&O, the B&O, the Baltimore and Ohio Railroad, which was a very important railroad, had been standardized. They were already talking about the Chesapeake line being standardized. All these lines are standardizing. By standardized, I mean the same width. Not a monopoly, a standard, right? There is no like big shadowy organization that makes a ton of money because we have these in our house. There's no one like secretly like, yes, my little minions, make me money. It's just the standard. It's not a monopoly. A monopoly implies there's someone doing it. What happened was states, their own railroad lines were different widths. And so what would happen is if you build a locomotive that worked in Virginia, it wouldn't work in Tennessee. And so you would get to the state line of a Virginia railroad in Bristol and have to unload everything in Bristol and load it onto a train that worked on Tennessee Railroad, which was it was a logistics nightmare. You couldn't just have the same train go. So this is what we mean by standards. That's the benefit. We take for granted, why are lanes on the highway the width they are? Why aren't they twice as wide? Why aren't they half as wide? Well, because they need to accommodate a wide range of vehicles, but there is a trade-off. The wider it is, the more asphalt we need. So we kind of found a happy medium such that it can accommodate, most roads can accommodate trucks, but not much more than that. So it's just a standard. That's the benefit. Anyway, so a very practical example. Bases itself, and it's called comparable, and we've actually, you may have seen it before. Right, superclasses also provide some form of standardization through their abstract methods, but again, there's a hierarchy. So a train is not a descendant of a railroad track. A train uses a railroad track. So a train is the train which adheres to the standard railroad track is not itself a railroad track. Whereas when we're talking hierarchies, we're talking about an is-a relationship. We're saying that, like, a train is a vehicle. That's a hierarchy. But a train is not a railroad track. It uses a railroad track. It uses that standard. A space heater is not a power outlet, but it uses the power outlet, and it's a standardized power outlet. That's the difference. So one of the most common standards used is called comparable. And comparable has one method. Public int compare to. This is a standard method. And string uses this standard. And here's what I mean by that. New class string demo. And by the way, don't get me wrong. Interfaces and abstract classes are similar, and if you understand one, it's easy to understand the other. I just want you to understand why the motivations for when we use an abstract class are different from when we use an interface. Interface, we're adhering to a standard. Abstract class, we're talking about an is a relationship. That's kind of the two use cases. Public static void main string args. String has a very useful method. I'm going to make a few string, or let's do, I'm going to pull up my other slide deck. This is the compare to method. And with the compare to method, it takes in two strings. Well, actually, it takes in one string. It's called on one string, passing another as an argument. And it compares string A and string B. So it would be something like string A dot compare to string B. And this returns a number. And that number is either positive, negative, or 0. That number tells us the relative positions of those two strings. So, for example, if I had cat.compare to dog, this line prints -1. And what this implies is that cat, the thing that comes first, is less than dog. Similarly, I have eagle.compare to cat. That gives me +2, which implies that eagle is greater than cat. So a positive result means that the first thing would come after the second thing. A negative result means the first thing would come before the second thing. So this is actually based on the ASCII values, not based on the alphabet explicitly, but based on the numeric ASCII values, which we've talked about that before. But that happens to be alphabetical, right? A is less than B, is less than C, is less than D, ... is less than Z. It's alphabetical. So because cat comes before dog alphabetically, we get -1. And I can show this here. I can just simply copy these 4 lines, put them into Eclipse, and you'll see that I get the results I say. -1, 2, 16, and -4. The reason we have to do this is string does not support these operators. Well, etc. It doesn't support these. So if we wanted to, say, alphabetize a list of strings, we could do it using this compare to method. So again, cat less than dog, because cat would come before dog in the dictionary. Eagle greater than cat, because eagle would come after. So again, if the result, let me do it this way. If result is negative, first thing comes before second thing in order. Well, in ascending order. If result is positive, actually I'll just say in order for now, because we'll do an experiment with this later. If result is positive, first thing comes after second thing. Now, of course, in addition to positive and negative, there's always 0. 0 is neither positive nor negative. If result is 0, the two values are equal. So, for example, if I said system.out.println cat.compare to cat, this is going to be 0. And it's going to be my third value down, so I'll highlight it. There you go, 0 here. That means those strings are equal. So this compare to method returns a number, and that number dictates order. Now, we don't care about the actual value of the number. I do not care that this number is 16 and this number is 2. I don't care. All I care is that this number's positive, that number's positive, that number's negative, that number's negative, and that number is 0. All I care about is the sign. The sign tells me the order. The actual specific number, it's kind of irrelevant. But then you can see things like bed comes before bedroom. You know, cats comes after catcher because S comes after C. You get the idea. Any questions about the string compare to method so far? Great question. Capitalization. So keep in mind, one limitation of this is that ASCII values are case sensitive. And as a result of this, capital letters, capital AAA compared to lowercase AAA is negative. So that would mean that in this case, while it seems strange, if we did use the compare to method for alphabetization, then zebra dot compare to aardvark, this is actually going to be negative. And the reason it's negative is because capital Z has a smaller numeric value than lowercase a on the ASCII table, which we've talked about before. Again, not expecting you to memorize the ASCII table, but it is worth knowing. It is worth knowing that capital letters have a smaller value than lowercase letters. One way to get around this, by the way, if you're ever trying to make something case sensitive, is just make all the strings uppercase. And the way you can do that is, let's say I had string S equals SpongeBob text. And if you get the meme, good for you. You can make this string all uppercase by saying S equals S.to uppercase. System.out.println S. And it prints SpongeBob text. Or you could make it lowercase. The point is, make it all SpongeBob SquarePants, by the way. The point is, make it all I'll create one, sure, but they have to be safe for work memes. That's the rule. So that's a way you can make everything the same case by just converting everything to uppercase. But now let's start seeing how this compare to method can be used. Let's say I have a list string. List string words equal new array list string. And I do, so let me do my imports here. Words dot add cat. Words dot add capital C cat. Words dot add zebra. Words dot add aardvark. Words dot add beagle. Words dot add unicorn. Let's say this were my list of words. It turns out that Java can sort this list for me. Java sorts this list, and it sorts it in a very simple way. There's a very simple function you can use. Collections.sort words. And if I do that, system.out.println words, you will notice that it sorts the words in not alphabetical order, but ASCII order. So capital C, cat, comes before capital Z, zebra. Capital Z, zebra, comes before lowercase a, aardvark. Then beagle, cat, unicorn. So we can almost use this to alphabetize words, but we would have to go through and make every word uppercase. Or do we? But first I want to take note. How do you think Java is sorting this list of words? What method do you think Java is using to sort this list of words? When I say collections.sort, what method is it using? Compare to, exactly. Why do I spend all this time talking about compare to? Because it's using compare to. You just mentioned a great point. Tree sets. What about tree sets? What if instead of this being a list, let's say I made this a tree set. Tree set, words set. And make this a tree set. Remember, tree sets are automatically sorted. So I can just say system.out.println word set. But how does the set get sorted? How does Java know? Oh, sorry, I forgot to change this to words set. But how does this set get sorted? How does Java put it in the same order as collections.sort? It uses it. Yes, it does use loops, but it uses inside of the loop the compare to function. It uses the compare to function. Because the whole point of sorting is you're just going to look at two things and you're going to say, okay, which of these, let's say I'm sorting in ascending order by which can has more Coke in it. This one's empty, this one not empty. It will look at these two things and compare them. And if I have 100 cans, I still have to look at two at a time to perform the sorting. And that is done using compare to. So tree sets use the compare to as well, exactly. They all use compare to. Why? Because compare to is this. Compare to is a standard. It's a standard for how we compare two things of the same data type. And that method is within the interface comparable. Oh, sorry, yeah, well, my problem is I'm actually, at a point where I get seriously bad headaches and get dizzy if I don't have caffeine, which probably means I should stop, but here's the dying in my 40s. Anyway, sorry, the real feelings came out there for a second. Let me bottle them back in. All right. So with that, the interface is comparable. So now let's take a look. I've uploaded some code today. And what I'm going to do is I'm just going to quickly drag some of that over. And I'm going to take a look at the student class. But for now, I'm just going to start simple. I'm not going to start with the finished product. Let's say that I have a student class, and I'm, just to avoid confusion, going to delete these override keywords for now. Let's say I have this student class. This student class defines a name, an ID, and let's say a final course score out of 100. Now, this is fairly standard, right? I made all these public just to be easily accessible. Should I make them private and give them getters? Yes, but we're fine for now. I have a standard constructor, and I have an equals method. Two students are equal if their IDs are the same. Right? This is all nothing too surprising here, right? And then I print the name, the ID, the score. Now, let's take a look at this tree set I made. This is a tree set, and I put in a student Aaron with ID 1234 out of 88, Betty 9876, 99, etc. So I'm just going to create 3 students which implement this class. I'm going to put them into a tree set, and I'm going to print it. And let's see what order they get sorted in. Oh no, my code crashed. I never expected this. I expected this. What happens here is that I cannot put something into a tree set unless it adheres to the standard comparable. It has to adhere to that standard. When it tries to do when it tries to sort the elements, I get this class cast exception. And the reason it gives me this error is it says student, the class student, cannot be cast to Java Lang comparable. So if I want to put any class into a tree set, I can't, unless I make sure that class adheres to this standard comparable. So you may think, okay, well, all right, let's, instead of a tree set, let's maybe just put these into a list. Let's do an array list. And I can do that. I can put these into an array list. And I can run it, and it will print, but I still can't sort this. If I try to do collections.sort students, this doesn't compile. This doesn't even compile. I can't run it. And that's because if I don't implement the standard comparable in the class student, if I don't adhere to that interface, then I cannot do any sorting with any of the built-in Java tools. Could I write my own code to sort a list of students? Yes, I could absolutely, without writing a compare-to function, writing any other function I want. Could I find a way to do it? Absolutely. But it would take a lot more work, and it would be much less reusable. Whereas, if I just agree to adhere to the standard, implements comparable, and specifically I'm comparing student, so you would say implements comparable, and then like an array list, you say the type you're sorting, which is always the type of the class. So while this looks a bit redundant, this is the right way to do it. Now I can adhere to that interface, provided that I implement the interface the function requires. And the function that is required is this one. Public int compare to. And it takes in some student. I'll change this to S. So this is how I compare this student to another. So I would say something like Aaron.compare to Betty. So now I have to define how I'm going to sort my students. But this brings up a valid question. How should I sort my students? Should I sort them by name? By student ID? By exam score? Well, it depends, right? You could imagine situations where I want to sort the students by name. I know a student's name. I'm looking for a student, right? You could also imagine a very valid reason I would want to sort the students by their exam score. Right? I want to know which students are doing well in the class, which students are doing poor. Similarly, I might need to sort them by ID because I have an ID and I'm trying to find the student associated with that ID. Right? All of those are valid reasons to sort. So, with all 3 being valid, I'm going to let you, the class, decide. How should I sort? Score, ID, name. Tell me. Tell me and I'll do it. I'm going to go off popular opinion. Cast your votes now. Text 1 for name. Text 2 for... No. All right, we're saying ID. Let's start with ID. That one's good. Let's start with ID. And actually, real quick, I'm going to change something. I'm going to make score a double, because this is going to come up later. Since I left it as an int at first, but for now, let's make score double. But let's sort by ID. So what I need to sort, let's say, in ascending order by ID. That means I would want Elton has the smallest ID to come first. Betty has the largest ID. She'll come last. So what I need is a function that compares two students by their ID. If the calling student, because remember, this is A dot compare to B. So if A's ID is less than B, that means I want A before B. So I want a negative number. And if A is greater than B, I want A after B. So I want a positive number. So I could do something like if this dot ID is less than S dot ID, return -1. Else, if this dot ID is greater than S dot ID, return +1. Else, return 0. Because they're equal. This works. And if I do this, now notice I have my compare to method. This implements comparable. Now, I've changed nothing in this code. It now compiles. Even though I changed nothing in this code. Because student now implements comparable. It adheres to that standard. And if you look, notice the students sorted in ascending order by ID. Can anyone think of a way to do this? Get the same result, but without an if statement? Anyone think of a coding way to do this more efficiently without an if statement? No loops, no if statements. Here it is. Return this dot ID minus S dot ID. That's it. Because, think about it. What if this dot ID is less than S dot ID? What will the value be? If this dot ID is less than S dot ID, it will give me a negative number, right? And if this dot ID is greater than S dot ID, it will give me a positive number. And if they're equal, it will give me 0. So, this problem does the same thing. Because remember, I don't care about the actual value. I treat 1 and 5,000 exactly the same. And I treat -1 and -5,000 exactly the same. I don't care about the magnitude of the number. I only care about the sign. And when I do that, collections.sort still works. Let's run that again. Better, now I don't even need to make this a list anymore. I can make this a tree set. I no longer need to sort it. Pardon me. Sorry about that. And now you'll see that the tree set prints them in ascending order. Given what I just did, I now have a question for you. What if I want this to be descending order? Can anyone tell me what I need to do to make this descending order? How can I make the tree set be descending order? Because right now it's ascending. How can I change this function to make this descending? I could multiply by -1. That's an option. -1 times this. I could also just flip this an S. I assume you probably said something dot. Sorry about that. It's a pretty aggressive. Yeah, sorry about that, T on you. It's an aggressive thing just because it's trying to block web addresses. But yeah, I could switch the order too. So instead of multiplying by -1, I could just do S minus this. And let's do that. Okay? So now, here's a question. What if instead of this, I wanted to sort by name? What if instead I wanted to sort by name in ascending order? Can anyone think of how I'm going to sort this by name in ascending order? How am I going to sort the students by name? Well, the name's a string, right? Does anyone remember how we can compare strings? I forgot. How can we compare strings? Compare to, exactly. So, why don't I just say return name.compare, or this.name, and I don't need, I could just say name, but it just helps make it more readable. This.name.compare to s.name. There you go. Now we're sorting by name. I save this, I rerun the code, and now Aaron, Betty, Clint, Debbie, Elton. I can just as easily then do reverse alphabetical order if I wanted. I could do S and this will give me the opposite of that. Sorry, S.name dot compare to. Right? Now this will give me reverse alphabetical order. So now here's a question. The score is a double. If I wanted to sort in descending order, doesn't it get messed up? What if the names are lowercase? Yes, that is a problem. So if some of the names were lowercase, let's say this were lowercase c Clint, this does get messed up. Notice that lowercase c Clint comes first. We could fix this, however. If we wanted to ignore case, we could do the following. Simply do, remember, s.name is a string, right? This is a string. So I can do what to this string, whatever I want, like to uppercase. And then to uppercase, by the way, gives me a string. So then I can say this.name.to uppercase. And if I do this, now notice that because I took case out of the equation, now Clint comes in between Debbie and Betty. All right. So now let's consider score. Can I do the following with score? And for now, I'm actually going to... There's a reason I'm writing a comment here. Just trust me on it. Can I do the following? Return this.score minus s.score. Am I allowed to do this? Yes or no? Assuming I comment this out. Exactly. This wouldn't compile. Because this is a double. Now you may think, well, why don't we just convert this to an int? You could do that, right? Well, you can't. You can't do this. Because this will result in inaccurate behavior. Consider this.score equals 72.2 and s.score equals 72.1. 72.1 minus 72.2, or sorry, 72.2 minus 72.1 is 0.1. What is 0.1 casted to an int? 0.1 casted to an int is 0. And so these two numbers are apparently equal now. So there's a couple ways to do this. One, the most obvious way is just to do if. You just have to do the if statement. If this dot score less than s dot score, return -1, else this dot score, else if, excuse me, this dot score greater than s dot score, return +1, else return 0. You either have to do this, or there is a shorthand version. You don't have to memorize this, but you're welcome to use it on exams. Return doubles dot compare this dot score s dot score. Sorry, double dot compare. This is a function that will effectively do this. This is a built-in Java function, and all it does effectively is this. And if I do that, you'll notice the students are now in ascending order in score. If I want this to be descending order, -1 times that. And again, this function just does this. That's all it does. If you forget this function and write this out on the exam, completely fine. You will get full credit. You will not lose points. Like, no problem with that at all. Just, this is worth remembering. It's short enough. Any questions about how to write this compare to method? So here's what we're going to do. We're going to take our 10-minute break, starting now. I will come back at 2:20. But go ahead and get started on the daily activity. Wait, no, you can't yet, because we haven't talked about Comparator. Never mind. Okay, you can't get started on daily activity yet. We haven't talked about Comparator. We'll do that after the break, but we're going to take our break now. So I will be back at, let's make it 2:19. Shouldn't take too long. And we will pick up from there with Comparator. right, everyone, we're back. Here we go. Jumping right back into it. So, we were talking about the compare-to method. One key rule of the compare-to method is it lets you tell Java exactly one way you want your objects sorted. But here's the problem. We often want to sort objects multiple ways, right? Take, for example, this Wikipedia page. This Wikipedia page is the list of United States states, got away from me there, and their population rank. So I can sort them by their current population, which is estimated, or I can sort them by their census population. The last census officially with results is April 1, 2010. I can sort them by their number of U.S. House delegates. I can sort them by their estimated population per House seat. So, for example, you can see that Rhode Island and Wyoming have the most citizens per House seat. West Virginia, my home state, is third in that respect. Whereas Montana has over 1 million people and only one representative. Right? So this is multiple sorting techniques. And I can switch, as much as I want, I can switch how I want to sort that, whether descending or ascending. I have that control. Problem is, Java only lets me have one compare-to method. Just one. So how can I do this? The short answer is, I can't. I can't have multiple compare-to methods. I have to pick one. And that one compare-to method you can think of as the default order sort. I want to compare, by default, the students by some field. And let's say our default sort is to just sort the students by ID in ascending order. Return this.id minus s.id. This is my natural order, is what we'll often call this. Natural order. And in this case, it means sort by ID in ascending order. I can make other sorting techniques, but they have to be in a different class. Comparable only has one comparison method, compare-to. And each object can only implement comparable once. But there's another interface. And that interface, which is very, very similar. So I'm going to write this out here. Comparable has the method public int compare to. And this is comparable, some generic data type E. Compare to takes in some argument E. Comparable. Comparator is very similar. Comparator, E, is public int compare E, A, E, B. That is, rather than comparing something like A.compare to B, we are going to write compare A, B. And these two methods work the same way. That is to say, if A less than B, negative. If A greater than B, positive. If A equals B, 0. They both follow this rule set, but you call them differently. And the reason is comparator, so comparable has to be attached to the object that you're comparing. This class has comparable in it. Comparator does not have to be attached to this class. A comparator's job is to compare two different things. Comparable is to say, I need to be able to compare myself to something like me. A student has to be able to compare itself to a student, has to be able to compare, comparable. A comparator is some third party, some arbitrator, who looks at two things and says, this one is less or this one is less. And so we can write a class like new class student, and let's go with name comparator. And student name comparator implements comparator student. That is, I'm comparing two different students in this class. And now you may be thinking, oh no, we're going to have a whole nother class. This class is going to be very, very, very short. In fact, we've already defined every method that this class is going to use. It only has one. This class solely exists for one purpose, to compare two students. And we're comparing them by their name. And how can we do that? Well, we've already done it. And I'm going to change the variable names. Instead of arg0, I'm just going to call this S0. Oh, I have insert on. S0 and S1. Simply return S0.name.compareTo, or let's actually do the case insensitive one. So to uppercase dot compare to S1.to uppercase dot, or sorry, S1.name dot to uppercase. Now, I have a separate means to compare students. So I have the default order, which compares them by their IDs in ascending order. And now I have a second separate order, which is to compare students by their names. So I'm going to leave this up on the screen for a second. But what I want to emphasize here, the class student has the option to implement comparable, but it can only have one comparable method, one compare to. I can make 100 of these classes if I want to. I can make 100 comparator classes if I want to. In this case, I'm making one for now and I'll make another later. But I can make as many comparator classes as I need. So from there, now let's go ahead and actually use this comparator. So in order to use this comparator, I have my list of students. TreeSet has two constructors. This constructor uses student.compareTo as sorting method. There's a second constructor, TreeSet student. I'm just going to copy it here, actually. The second constructor, and I'm going to comment these lines out, takes in a comparator object. And that comparator object is made simply by creating an instance of this class. New student name comparator. This constructor uses the input comparator's compare method when sorting. So it's going to go to this class, use the compare method. This may seem a weird way to do it, to create an instance, but this is just the way Java decided to implement it. Why use compare to versus comparator? Again, because comparable is added to student, and I make the student, this is telling the student, I'm going to compare yourself to me. Or I'm going to compare, this says to the student class, you have the means for each student to compare itself to another student. But you can only have one compare to function. By making a comparator, I can make as many of these classes as I want. Let's make another one right now. I'm actually not going to make it. I'm just going to copy and paste it in from my notes, and then we'll take a look at it. Hang on. There we go. The window wouldn't come up front. So now let's say I wanted a score comparator. Here it is. This is a score comparator. Only it's I forgot that I had changed score to int, so let me do return double dot compare. There we go. So now I have 3 ways to sort, but one of those ways has to be the natural order. The natural order is the one that's defined by the compare to method. But again, I can only have one. Now I can have as many comparators as I want. So let's say instead of by name, I now want to sort by score. Well, I can go to this tree demo, and instead of student name comparator, I just change this to student score comparator. Again, if I have no argument, it uses the student class's own compare to method. This one will completely ignore the student class compare to method. It will not use it. It will use this class's compare method when sorting. And so now when I sort, you can see I get ascending order 77, 82, 88, 93, 99. I'm going to make a change real quick. I'm going to change, let's say that Aaron submitted a regrade request and got 93 instead. So if Aaron got a 93 instead, well, now we have a problem. What happened here? Well, here's the thing about the comparator method, and it relates to tree sets. Remember, trees are a set, right? How many unique elements can a set have? Or given a unique element, how many of the set can have it? 1, because sets are unique. I can't have, for example, in a set of words, I can't have the same word twice, right? Well, the problem I now have is I have 2 students with the same score. And so even though they aren't the same score, because my student score comparator returns 0, the set assumes they are equal and it rejects the element. So what I need is I need to say not just sort by the score, but I still need to make sure that if the students are different, it doesn't give me 0. So the way I'm going to do this is I'm going to change what I want this class to do. This class will sort by score first, and if scores are equal, then sort by name. The reason this didn't work before is because if it says the 2 elements are equal, tree set assumes they're duplicates, even if they're not. Just because both of them have the score 93, they cancel each other, or one of them cancels the other out. So I'm simply going to add an extra condition. So I'm going to say the following. If double.compare equals 0, that is, if the scores are equal, then I'm going to return o1.name.compare to o2.name. And we can go ahead and put the 2 uppercases in there as well. 2 uppercase and dot uppercase. Just so they're case insensitive. If they are not equal, else, that is, if they're not equal, then I simply just return that. Now I'm sorting by 2 conditions. I'm sorting first by double compare O1, O2. This takes precedence. We sort by the score first, but if the scores are equal, then we alphabetize the students. Let's go back to tree set demo. And now you'll notice both Aaron and Clint are in the list at 93. Aaron comes before Clint because Aaron's name alphabetically comes before Clint. So this is how we can sort by multiple criteria. Of course, one possibility now is what if we have another student named Aaron, but it's a different Aaron. They have a different student number. Right? This could happen. We teach, in this course, we teach over 500 people a semester. Chances are we have two students with the same name. Are they going to get the same score on the exam? Probably not, but it's possible. So we also need to include the student number. So I do the same thing. If these are equals 0, then I'm just going to return this dot ID minus O1.id minus O2.id. Else, return the string comparison. So this may seem a bit counterintuitive because if you look at these return statements, you'd think top to bottom, okay, first we do ID, then we do string, then we do score. But it's actually reverse order the way I wrote it. Score takes the first precedent. If scores are equal, then we sort by name. If score and name are equal, then we sort by ID. If I did this correctly, you'll see that I have two Aarons. I have student number 1, 2, 3, 4 and student number 2, 3, 4, 5. So they're not conflicting with each other. So, a rule with both comparator and comparable. This is an important rule. Same way we had rules with hash code, we have rules with compare and compare to. If A dot equals B is true, then A dot compare B equals 0 and compare A comma B equals 0. That is, if A and B are equal to each other, as you define your equals method, then A dot compare to B and compare AB, whatever your comparator is, should always equal 0. The converse of this statement is also true. Or not the converse, excuse me, the opposite of this statement is also true. By that I mean, if A dot equals B equals false, then A dot compare B should not equal 0, and compare AB should not equal 0. Because remember, 0 means they're equal. So if they're not equal, I want to design my methods such that this is almost never the case. Now, that's a general rule. As it relates to the homework and as it relates to the exam, we will tell you something like sort the students in ascending order by score, then by name in ascending order, then by ID in ascending order. This might be something we tell you on the homework or on the exam, and this is how you would do the sorting, if this is how I wrote it. First by score, then by name, then by ID. And we would make very clear to tell you ascending or descending. Are there any questions about comparator? Oh, how do you use comparator with collections.sort? That's a question, which no one asked, but it's a question to ask. Let's say instead of this being a tree, we go back to this being a list. If this is a list, pardon me, it can't take in a comparator at creation time. Rather, if we say collections dot sort, no, not check sorted map, sort students, this sorts using compare to. We can also do collections dot sort students, comma, new student score comparator. Sort using comparators compare method. So I can choose which I want to do. Either I sort by the natural order with the comparable method, or I sort using that comparator. The nice thing about comparators is you don't even need to have access to the class to use them. For instance, taking a step back, looking at our string demo. I talked earlier about how I have this list of strings. And if I do collections.sort, or if I do a tree set, well, my problem is the tree set's always going to sort the strings in ASCII order. But what if I want them in alphabetical order? How can I fix that? I don't have access. I can't change the strings compare method, right? I don't think, or the strings compare to method. I don't think Java's going to let me change the string class. Should I ask, guys? Maybe I should change it. Just hack Java. No, I can't change that class. But what I can do is I can make a new class, string ignore case comparator. I can make my own string comparator. Implements comparator string. From there, I add the unimplemented method. By the way, that override thing I keep deleting, you can leave it there or not. The problem is I already have a nickname. My nickname is already Will. My first name is Paul. It's not Will. I've been going by my middle name since middle school, so it would be Will and then like in a second set of quotes, the hacker, but still inside the first set as well. Anyway. I could just simply define my own way to compare strings. Return o1.to uppercase dot compare to o2.to uppercase. And I have just defined my own comparator. And now I can come back to the string demo, and when I define my tree set, I can say new string ignore case comparator. And then save, I then run. And now notice that these strings are sorted. And while I did lose one of the cats, I'm okay with that. Because I don't need the word cat twice. So there we go. Any questions? And I will upload... I'll upload this file as well, the string demo and the string ignore case comparator. Are there any questions about that? All right, so for the sake of time, while I do want to cover abstraction with generics, I'm going to let the next 30 minutes be exam content questions. And the first question I'm actually going to answer, just because it's come up enough, I'm going to go ahead and do yesterday's daily activity in front of you so you can see my thought process. No, you're still not right. It's Paul, Will, and then... Here, I'm typing it. There we go. That's how you got to do it. So I'm going to go ahead and do yesterday's daily activity just because there were enough questions about it. So I just want to work through how I would do it. I think all the other daily activities, most people seem to not have too much trouble with. But certainly this one, I saw enough people in office hours over it that I wanted to help out. All right. So I have animal, cat, dog, and vet. So the first thing the directions said to do was modify give shot to take in an animal argument. This is literally all that means. Animal A. And again, A is a variable name. I can call that Steve if I want to. So it takes in animal Steve. From there, I want to do something like, if this takes in a dog named Jake, print dog Jake after the shot cried woof. Don't humanize it. Have you heard me talk to my cats? My cat is named Stuart. That's about as human name as he's named after a human. I am closer to Stuart than I am to any human except my wife. That is the actual truth. It is like wife, Stuart, Morgan and Colby are like right below Stuart, and then like the rest of humanity. Anyway. From there, so I need to modify this. So the first part is, if I have an animal and woof is the noise the animal makes, well, let's break this down. This is class name after the shot cried noise. That's how I want to think of this. This is the string I am trying to generate. So getting the name of the dog, or the animal, is fairly easy. I have... I'm not... Just to avoid confusion, I'm going to change this to A, but it could very well have been Steve. Anyway, A.name plus after the shot cried. I've now done this part. Now let's do the noise part. Plus A dot make noise. Finally, I need to get the class name, and that's where we gave you this string. And technically, you don't need the substring part. This is code that gives you the name of the class. Just to illustrate, system.out.println a type. If I were to do this, class dog. Now, I don't want, actually the substring part, I don't actually want class here. So I want to eliminate the first 6 letters. So to eliminate the first 6 letters, I simply say dot substring 6. And it begins at 6, meaning it only gives me dog. Dog. If this, instead of being a dog, were a cat named Jack, then cat. This is just something that gives me the name of the class. So, string a class name equals, and I can just paste that line. And then, a class name plus, I'm going to give a white space there, so there's a space between the animal name and that. I am now mostly done. This function is now done. So here is how I would use it. I would simply say, okay, I've created the animal Jack, and now, granted, Jack is a dog in this case, but dogs are still animals. This function that takes in an animal can take in a dog, because dog extends animal. So a dog is a animal. So, give shot A. Even if A were initialized as a dog, this still works. Because of the hierarchy, because dog is a animal. So I wanted dog Jack cried wolf. Then I wanted cat, or I could even say animal B equals new cat Garfield. Give shot B. Animal M equals new. In this case, it just says animal. So animal in this case is not abstract, and it just makes a blank noise. So if I said new animal Marlowe, and then give shot M. Oops, I need to do print line. Let me do that. There we go. So I will make as much of this code visible. I'm going to delete my comments in order to accomplish that goal. Are there any questions about how I did this? Notice what I did not do. I did not do a.giveShot. That's because the class dog nor the class animal has the method giveShot. There's no giveShot method in animal nor for dog. The method giveShot is defined in vet as a static method, and so I call it as a static method passing in the animal. So this is the correct version, not this. Any questions? All right, so before we jump into general questions about the exam, a couple questions that I just don't tend to answer. Will blank be on the exam? Probably. Whatever blank is. If we have covered blank in class, the answer is very much probably. Bordering on very likely. If you give shot was non-static, no. If shot were non-static, what I would have to do is I would have to create an instance. Because remember, this is not inside of the class animal. So it wouldn't make any sense to say animal.giveShot. Because we're not in the class animal. We're in the class vet. You can't call a non-static method tied to a vet on something that isn't a vet. So what I would have to do is I would have to do something like vet v equals new vet, and then v.giveShot. 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 That's because of where the method is defined. So the method, you can't, the argument and the thing before the dot are not interchangeable. You know, the argument here has to be there. So that's the idea. But if the method is static, then we don't need to create an instance of vet. We can call capital V vet.giveShot, although since we're in the class vet, we can just call giveShot. So just ground rules again. I will not answer. Will blank be on the exam? The answer is probably. I don't know how many questions the exam has yet. I don't know how hard it is. I talked about that before class. So I can't answer those questions. But here we go. There is a quiz question about how Java always passes by value rather than by reference. Yes. So again, it depends on what your definition of value and reference are. So when we go back to, as I've said before, everything in Java is pass by value. So if I had, for example, a function that took in an array, and that array is defined in main. So let's say in main, I say something like X is an array, and that array contains the values 5, 3, and 1. This is my heap, and this is my stack. Well, this array is stored at some memory address. Let's say C0D4. That means the value of X is C0D4. It is not the array. So while this is a reference, when we pass X to a function, let's say X gets passed to some function like sum array, which is going to iterate through the array and get the sum. If this function, say, were to take in an argument array, and we passed into this variable the value X, the value here is C0D4, which, while it points to the same array, is still a different variable than X. So if, for example, I said in this function something like array equals new int 4. I don't know why I would do that. That would create a new array of size 4 with all the values initially 0. This would have, say, some new address. Let me do one that makes more sense. C100. That would change this address to C100, which would change this pointer to point to that, but X is unaffected by that change. So in Java, we're never passing a reference. We're not passing a reference to the variable X. If this were a reference to the variable X, this arrow would point to X. It wouldn't point to the heap, it would point to X. But it's not a reference to X. It copies the value of X. It just so happens that the value is a reference. But still in Java, all function arguments are passed by value. It's just what is the value. In this case, it's an address. And in the case of any reference data type, it is the address that gets passed. In the case of a primitive data type, y is the integer 5, it passes the value 5. So that's the distinction. But so in Java, everything is passed by value. But you should be aware that reference data types can result in the values changing, not just in some array, but also for main, at least on the heap. And if you want, go back and look at the lecture. We talked about pass by reference and pass by value, and I did examples with integers there. If you want some more practice with that. Any other questions? And I can pull that code up too. Not array list demo. Is it this one? No. Can't remember which one it is. I've uploaded an example though. I know I have it somewhere. Anyway. Any other questions about this is topics for the exam? And certainly you can ask about specific quizzes or specific daily activities. I can't talk about homework 1 because people can still submit it tonight by midnight, so I can't discuss it until then. You explain what a superclass is again. Is the object class the one and only superclass? No. The object class is like Genetic Eve, right? My mom is not Genetic Eve. My grandmother is not Genetic Eve. But at some point down the line, I am descended from some human that we call Genetic Eve, some very, very early human being. All of us are descended from that person. That doesn't mean that we have no other ancestors. We have other ancestors. They're just in between us and Genetic Eve. So, like, I am descended from my mother, who's descended from her mother, who's descended from her mother, and so on. So, for example, the equilateral triangle class, its superclass is triangle, not object. But the triangle superclass is object. So it's the same way that think of it like a species hierarchy. You know, me and my cat Stuart are both animals. We're also, you can get even more specific, we're both vertebrates. We're both oxygen breathing vertebrates. And you can, but then once you get down to, you know, it's above feline. I can't remember what it is. It's like the order above feline. That's where it will split between humans and what become apes. Or sorry, not humans and apes. It splits between the order that contains apes and the order that contains cats and dogs and stuff. So my super class as a human being is Homo, for, you know, Homo sapiens. And then you can go up the line, but eventually everything converges to animal. The same way that everything converges to object. So object is like the tip of the pyramid, but the hierarchy breaks up further down. So everything descends from object, albeit not always directly. What would a hash code question on the test look like? I can't answer that question. What I will say is you need to be familiar with the rules that we set up regarding hash code, so I encourage you to look at that, but I'm not going to tell you what a particular type of question looks like. The hash code is for deciding a bucket. So remember the idea of a hash set, and this only applies to hash set and hash map. Tree set, tree map do not use the hash code function. The only thing that uses the hash code function is hash map and hash set. And the hash code function takes in some object and it turns it into an int. We don't actually care about the exact value of the int, but the int is used if we have, say, a hash table of size n, n. If we have a hash table of size n, we have bucket 0, 1, 2, 3. This would technically be n minus 1 would be the last value. So we have an array of size a, it goes from 0 to n minus 1. Then we decide which bucket, let's call this object O. We decide what bucket to put O into based on O.hashcode. This returns an int. And this int is then we do mod n, get the remainder, and whatever the remainder is, that decides what bucket we use. So if O.hashcode modulus n is 2, we put O in bucket 2. That's how we use the hashcode function. So here's the thing. You don't actually have to worry about doing the modulus. The hashcode function does not contain the modulus. Right? So for example, I could make, you go to screen share, I could make student have a hash code, and it could just be as simple as doing something like this. Public int hashcode is return name.hashcode. I don't have to do the modulus operation here. In fact, I shouldn't do the modulus operation here. This is a valid hashing function. This just gets the hash code of the name. And I may find that satisfactory. If I'm worried about a lot of names overlapping, I could make it a little crazy if I wanted. Something like make this times 31 plus ID. Something like that. Just make it look a bit more random, a bit less predictable. This might be a better hashing function, but for the sake of this class, I don't really care. And it would be completely fine if we said something like, make the hash code of student based only on the name. I'm done. No, there are not n minus 1 buckets. There are n buckets. Right? Because remember, an array of 4 elements does not have index 4. This is index 0, 1, 2, 3. So if n equals 4, my buckets go from 0 to n minus 1, but I have 4 buckets. 1, 2, 3, 4. But again, when I put if I were to put students into a hash set, here is how I put students into a hash set. I simply just say, where'd my student demo go? Hang on. Here is how I would put students into a hash set. Hash set student students equals new hash set student. And then I would just simply say, I can't do students. Let's call this HS. Then I would just simply say hs.add, and I would do new student like this. I don't have to worry about how the modulus operation works. I taught you how the modulus operation works so you understand it, but you don't have to do it. What this does, I want to explain what this does. This is going to take the hash set with however many buckets HS has. I don't care, by the way, how many buckets it has, but let's say that's n buckets, and it's just going to do this student that I'm creating. It's going to call hash code on that. That's going to give it a number. Some number, let's call it, I don't know, 1, 5, that. Let's say that were the number. I'm making it up completely off the top of my head. Then it decides which bucket to use by doing that number mod n, but I don't actually care. I don't need to do any of this. Java does it for me. So this is all you have to do. I just want you to know that the hash set is not magic. That's all I wanted you to know. So I'm showing you how it works, so you understand broadly how it works, but you don't actually have to do any of this. Can you please go over the keywords static, final, and private? Private is the opposite of public. A private variable is a variable that can only be accessed inside of the class in which it's defined. So, for example, going to triangle. No, triangle's a bad example. Go to Pez dispenser. Where is Pez dispenser? In Pez dispenser, private means I can only access count inside of the class Pez dispenser. In Pez dispenser, I can do whatever I want with count, but outside of the class, I can't. Public is the opposite of private. Public means outside of that class, I can manipulate that variable. Private and public also applies to functions. I can call a public function in any class. I can only call a private function inside of the class. Final and static have nothing to do with public and private. I just want to make sure that's clear. It's not, something is not either static or final or private. It's not like that. Something can be private and static and final, or public and static and final, as I have with capacity. So static and final are not on the same dimension. Like, we think of it as, we have a dimension here, left to right, and this is most secretive to most public. Over here we have public. Over here we have private. And in the middle, remember we talked about protected as it relates to hierarchy. Protected. There's technically also something called package, but you won't see that in this class, so we don't care. Right? This is a dimension. Final and static are not on this grid. It would be like me saying, what is your favorite color? And you told me 27. That doesn't make sense. So make sure that we understand public and private is not on this gradient. I just want to, Public and private is on this gradient. Final and static are not anywhere on this gradient. They're different things. Final means once the variable is set. Can you explain the difference between a stack and a heap? I have, but I will do the best I can with it without actually getting into the data structures. So, final means that once the variable's initial value is set, it can never change. So, for example, character name is final. That means it's immutable. So after the constructor is over, I am never allowed anywhere in my program for any reason, I am never allowed to change the value of character. The character is set, and it will never change. Static means something belongs to the class. That is a shared variable. Static means that it is not describing any one instance. So for example, I can load a single Pez dispenser. I can't load the class Pez dispenser. But since every Pez dispenser has capacity 12, I share that variable by making it static. Stack in the heap. So I'm not going to get into how they work because we didn't get into how a stack and a heap work. We haven't talked about the data structures stack and heap yet. We will talk about stack after the exam. We will talk about heap in the last week of class. But the idea is when we are coding, and actually I'm going to use blue for this. When we are coding, we have two different memory locations because both sides are memory. We have the stack, we have the heap. And when we start our program, we create a function frame called main, and we run whatever main we're running. Whenever I create a variable, let's say I say int x equals 5 in the function main, that means I create in the stack frame the function, or the value x, the variable x, which contains the value 5. And primitive data types are never on the heap. So primitive data types are int, char, boolean, and double. So if I say double r equals 3.5, I create my variable r, and in that box I write 3.5. However, if I create something like a triangle, let's do a right triangle. Actually, that's probably a bad example. Let's do a student. If I created student s, I said something like, in the code here, student s is new, or I said something like student s equals new student Aaron 123493. Then at that point, the student is created on the heap. So I create space for the object. It has a name, it has an ID, and it has a score. And the name is Aaron, and the ID is 1234, and the score is, what did I say, 93.0, we'll say. If that's not it, I don't really care. Point is, it's a number. S is still in main. S is the variable pointing to this. Let's say that this starts at memory address C108. Then S does not contain the student. It contains the memory address C108. It points to that. The reference data types are created on the heap, but the variables still exist on the stack. When I call a new function, let's say I said I call a function like max27. So let's say my function were defined, and this is not on the heap. I'm just making a separate little space here. Let's say I had a function called max int a int b. And let's say in main, I call this function with the values 2 and 7. Then that creates another call frame on top of main, referencing that function max with the local variables already set a2 and b7. Once that function is done, and then let's say it says return 7, then 7 gets returned to main. So this is the return value coming back to main, and then this function gets removed from the stack. And we're always running the function on the top of the stack. Main is always at the bottom. When main is the only function here, we're running in main. But once main calls a function, we run that function to completion before returning to main. So I did do an example, an illustration of that when we went over this in class. I believe it was on June 17 is when I did that. So I would encourage you to take a look. For the sake of time, I can't really spend more time than that. I'll stick around for another couple minutes and be willing to answer questions if there are any. But I'm not going to do any new material today, so lecture is over. But if you have questions, get them in now. I can stick around for about 5 minutes. There are office hours at 3:30 as well, and you're certainly welcome to ask for exam help there. So all the indexes of the list are gone after you use the sort. They're not gone, it's just things move. Right? So let's say that my list looks something like... let's say I had a list. This is not stack or heap related. Let's say I had a list of integers. And the integers were 5, 2, 7, and 3. These indexes are 0, 1, 2, and 3. This is my list. And I'm drawing it the same way as an array, so think of it like an array list. If I called sort on this, ultimately this list is going to become, because I'm sorting in ascending order, 2, 3, 5, 7. But, I mean, the indexes are still there. It's still 0, 1, 2, 3. These indexes haven't changed. It's just the values at those indexes are now in sorted order. So the indexes aren't gone. I can still do .get2, for example. It's just, before I sorted, get2 gave me 7. After I sorted, get2 gave me 5. All the numbers are still there. They're just in different places now. And that's just because when you sort, you reorganize things. And I know I haven't gone over the mechanics of how the sorting happens. Can you have a method be defined inside of a main method? Okay, there's a difference between can you and should you. And I'm going to tell you that you should not. You should always define your methods at the class level. You should never define a method inside of a method. Are there special circumstances where it would make sense to maybe do that? Yes, but you're not going to face any of them yet. Because you're not dealing with any problems where that is a good solution. So if the question is can you, my answer is there are ways. If the question is should you, my answer is, for now, absolutely not. I would not encourage you, no. Are there ways to do it? Absolutely. There are ways to build a rocket. I shouldn't be trying to do that, if that makes sense. It's a weird metaphor, but... And for the federal agents now listening, no, I'm not trying to build a rocket. It was an awkward metaphor. Leave me alone. Any other questions? The sort method, well, so there is no method to compare. There's compare to, and there's compare. As I talked about today, it depends. You can call the sort method in different ways. And I spent quite a bit of time on that, so I would encourage you to go back and look, but I'll show you which file I was talking about. String demo. I can sort this in 2 different ways. I could sort it with collections.sortWords. That uses the comparable compare to method. Or collections.sortWords. Sort words, new string ignore case comparator. This one uses string.compare2. This one uses string ignore case comparator.compare. That's the difference. So it depends on which sort you're wanting to do. Are you wanting to do the natural order sort? Or are you wanting to use a comparator? You can do either. So you're not always going to do one. Sometimes you'll do this one, sometimes you'll do that one. Just depends on what you want. The point is the comparator gives you flexibility. Compare to, you can only have one compare to method. You can have as many comparator classes as you want. So you can come up with 1,000 different ways to sort students and just implement the comparator for them and then just use the one you want at that time. That's the advantage. All right, I got to cut it off there. Take care, all.